pre-calc, you should start to recognize now the patterns of, it'll focus in a second, when you move something left, right, when you move something up, down. So this is inside the function, so this is left, right, and because it's -1, we know that means it's to the right. So the asymptote that would usually be, the vertical asymptote that would usually be at 0, this graph is pushed 1 unit to the right, which means that the asymptote is now going to be at 1. So it now has a vertical asymptote at x equals to 1, which used to be at 0, right? Because everything is pushed to the right 1 unit. And then all those points that we just drew, you can see that everybody's going to be to the right 1 unit. I can help you with that. So like if this is 2, 2 minus 1 is 1. We already did this point. Log of 1 is 0, because 2 to the 0 is 1. So at 2, you're going to be at 0. So you can see everything here is going to be very similar. This point just moved over 1 unit. You're going to see that this point will move over 1 unit. You can see that every point I have is here just going to move over 1 unit. All right, 3. 3 is a good point because 3 minus 1 is 2. So that makes it log base 2 of 2, which we know is 1 because 2 to the 1 is 2. So the point 3, 1. All right, I won't overkill this. I'll do 3 1/2, or 3 halves, which is 1 1/2. So if you subtract 1 from that, that's a half. So that's log base 2 of a half, which we said earlier was -1, because 2 to the -1 is a half. So that's right here. And really, this would be ideally what I would want from you. I'd want a vertical asymptote and 3 points. If you do more, that's great, but this is ideally what I'm looking for. And then you can see that this graph, each point on this graph is shifted over 2 units, which is what's making this one. All right, now if you put a negative in front, that's going to reflect it over the x-axis. So you can see that this shape's just going to flip upside down. Again, you're not pushing it left or right, so it's still going to have that VA at 0. But you're just going to notice all your output values are going to have a negative in front of it. So like if you do 1, it's negative log base 2 of 1. The output of this is going to be 0. -0 doesn't do anything. Okay, so let's do this one. So, all right, so this part here is going to be a 1, but then you're multiplying it by a negative, which is why it becomes -1. So like if you do 4, this part here is going to be a 2, but then you're multiplying it by a negative, so you get -2, and so on. Let's see, so this one is 1, 0, 1, 0, 2, -1, 2, -1, 4, -2, and then if you put in a half, that's going to be -1, negative and -1 is 1, so a half is going to be 1. Right, so this is going to reflect it over the x-axis, so it's going to flip it. So it's going to end up looking like this. Okay, so that's a reflection over the x. Now, if you put the negative inside versus outside, if I just rough sketch that for you real quick, since the domain of this is x has to be greater than 0, if I divide off the negative, that now means that x has to be less than 0, because then I have to flip the inequality sign. So you're still going to have the VA here, but you're going to notice now that this graph takes all negative values to negative the negative. So this guy is going to reflect over the y-axis. You have to pick, when you pick values in your table for something like this guy, you have to pick values like -1, -2, -4, because when you plug it in, when you, like, for instance, put in a -1, you have to negative the -1, so you're doing log of +1. When you put in -2, you have to negative the -2, so you're doing log of 2, and so on. That's the logic with that. And so on. So you're getting -1, 0, which is right here, -2, 1, and, you know, a -4, 2, and so on. You're going to get those points on your graph. All right, so just like I said earlier, you have to know your left, right, up, down shifts and your reflections. So this one is outside of the log, so this is going to push the graph up. I have marker all over your hand, my hand, if you're wondering what all the blue stuff is. So this is going to actually push the graph up. So you're not moving it left or right, so you're still going to have that vertical asymptote at x equals to 0. It's just that the graph itself is going to be all the y values are going to be 2 units higher. So I can still use all those good values we did before, like we can still use all of those, like a half, 1, 2, 4. We can still use those. It's just when you get your answer, you have to add 2 to it. So again, 2, this is going to be a -1 here. So you're doing 2 plus a -1, which is going to be 1, because this part here is going to go to a -1. This part here is going to go to the 0, so it's actually 2 plus 0, which is 2. These are all, I keep using the same value, so I'm hoping at some point it'll stick. This will be 2 to the 1 is 2, so this is 2 plus 1, this is 3. This part here is 2 to the 2 is 4, so this is a 2, so 2 plus 2 is 4, and so on. So you're going to notice that the graph is like pushed up. Okay, so at 1/2 we're at 1. At 1 we're at 2. At 2 we're at 3. At 4 we're at 4. Let me see if my brain is registering, if you guys know how to do the x-intercept. That means you have to set this equal to 0. Let me just do this on a side piece of paper. My brain's just seeing if I'm very visual, so my brain's seeing if you guys can actually solve that. This would be for the x-intercept, because you're letting y equal to 0. So you'd have to move the 2 to the other side. Yeah, you guys would know how to solve this. So you rewrite it now, 2 to the -2 equals to x, or x is equal to positive 1/4, because this would flip it down. Okay, so it's 1/4, comma 0. All right, so something like that I would expect you to do on your graph. So let me just say that a little slower in case I said that too fast. I was trying to check if you guys could actually do that yet. All right, so I took this function, and to find the x-intercept, you have to let y be 0. So I let this equal to 0, and I haven't taught this yet, so if you don't understand it at all, it's okay, because I am going to teach this. But when you solve a log, you have to isolate it. So the first thing I did was I moved the 2 to the other side. Now, to solve for x here, I'm going to convert this to its exponential equivalent. So the base to the exponent equals this. The base to the exponent equals this. And then you can solve this, because a negative means reciprocate, right? The negative means that negative means move the 2 squared to the bottom, and then 2 squared is 4. And so that gives us the point that if we plug in 1/4, we get out 0. So 1/4, we get out 0 like this. All right, so now I can draw my graph. So this is why it looks real tight in, because it's pushed up, and then it bends. Okay, so that should look to you from our original graph. You see that should look like higher. It's pushed up. It's like it's more flat against the axis before it starts to bend, okay? All right, gang, so that's really what I wanted to cover. I wanted to cover the basic shape of the log and how you move it left, right, up and down, and how you reflect it, and then just what I did at the very beginning with converting the forms. That's really all I need you to do at this point, is have the graph down and be able to convert the forms. Okay, gang, that's it. This section's not super long. All right, catch you next time. Bye-bye.